right, so here's 2006, question 4. This would be a non-calculator problem in this test. And it's given a table of time and velocity. We should immediately think to ourselves, time and velocity is going to give us an area under the curve of simply feet in this case, because it's feet per second times seconds. So it says rocket A has a positive velocity after being launched upward at 0 feet at time 0. So, at time 0 it has a velocity of 5. It's recorded for 80 seconds and it's shown above. And here's the big thing I want you to see. 5, 14, 22, 29, 35, 40, 44, 47, 49. Guys, do you agree that the velocity is always increasing? So guess what? That means the derivative of the velocity is always positive. The acceleration of this rocket is always positive. All right? And it says in the first thing, find the average acceleration of the rocket over the time period of 0 to 80. Indicate units. The big thing on letter A is that we understand then that we are simply finding the average. Right? So it's V80 minus V0 over 80 minus 0. So I go to the table. V80 is 49 minus 5. Let's be clear, the units on top are feet per second. The units on the bottom are seconds. We take the math here, we do it. 44 divided by 80 and simplify. I think you get 11/20 feet per second squared. And that is the answer to A. And it has to be the answer in the units. That's only 1 point. That is the average, not the instantaneous. That is the average. All right. Letter B. All right, letter B is what we were talking about before a little bit. Using the correct units, explain the meaning of the integral of 10 to 70 dt dt in terms of the rocket's flight. That's the first thing to do. Then it says use a midpoint Riemann sum to approximate that length. Now let's be clear. When in doubt, take a look at the units. Time times feet per second. So seconds times feet per second. This integral is simply going to give us, and it's a positive velocity everywhere. You guys agree? So this is going to give us the distance, right? You guys agree? It's going to give us the distance since it's always a positive velocity. Right? Or you could say represent change of position, but v of t is greater than 0 for everywhere in the interval, right? So I would write 10 to 70 vt dt gives the distance from time 10 seconds to time 70 seconds. All right, that's what that gives. All right. Then it wants us to do a Riemann sum. It wants us to do a 3-interval Riemann sum. Okay. All right. So does everybody agree the distance on this one is from 10 to 70? The distance in time is 60 seconds. So how long are each of my 3 intervals? 20 seconds, right? 60 divided by 3 is 20 seconds an interval. So when I look here, and I want to be clear, and I'm not going to write this out, because on the AP test, you wouldn't have time to graph this. I don't think you should. All right? I'm starting at 10, and I'm going to 70. You guys agree? And there's 10 to 30 is one interval, 30 to 50 is another, and then 60 and 70. You guys agree? So 10 to 30 is an interval. Oh, and I should draw this a little more symmetrically. You guys agree? 10 to 30 is an interval. 30 to 50 is an interval, and 50 to 70. All right? They're all equal spaces. Okay, it looks a little weird on the chart at the top. They're all equal. 20 seconds per interval. What's the midpoint of 10 and 30? 20. What's the midpoint of 30 and 50? 40. What's the midpoint of 50 and 70? 60. So if I'm going to do a Riemann sum here, I just want to make sure that I write it the proper way. I would write midpoint Riemann sum, and I would actually notate 10 to 70 vt dt. Does everybody agree that 20 seconds is my width of my rectangle? I would probably notate it this way. I would say my times are, I'm going to take v of 20 plus v of 40 plus v of 60. Now it's just math. But that's how you approximate the midpoints, right? So now, think about the units here, guys. It's 20 seconds times what? Well, it's times 22 feet per second, 35 feet per second, and 44. When you multiply it out, you're going to get feet on all three. So I would just do that substitution as my last step. You take 20 times 22 plus 35 plus 44, and I would just write feet right away. Try to save myself a little bit of time here. Do some math. Don't make a math mistake, hopefully. It's a big number, but it's 100 in there. No, 101, I think, because it comes out 2020. Right? Feet. Everybody, the explanation was a point. That you had those three values get used. Either there or here is a point. And finally, the answer, 2020, with the units feet. With the units feet is a third point. All right. This is one of those times, this problem left, that was a point for the first, 3 for the second. That means there's 5 points for the third. So this is one of those times to really do well in the AP. You actually got to really grind some of the last one out, okay? So it's a problem now. Rocket B is launched upward with acceleration by that function, 3 over the square root of t plus 1. Feet per second, feet over second squared. At time t equals 0, the initial height of the rocket is 0 feet. And the initial velocity is 2 feet per second. Which of the two rockets is traveling faster at time 80? Well, explain your answer. Everybody, time 80, do we agree rocket A is going 49? So now we just got to calculate how fast is rocket B going. All right? And everybody, if A of t is equal to 3 over, and I'm going to bring up that radical, 3 times t plus 1 to the negative half, you guys agree?
Excuse me for the time. Rocket club from 5 to 7 tonight. There will be a rocket club from 5 to 7. Also, just a reminder.
How is that for timing? Rocket club tonight. All right.
Thank you.
All right. Does everybody agree with the two initial conditions I threw on the board? You can throw it on my desk. I'll give it to you tomorrow. At the time of t seconds, the initial height is 0 feet. I'm pretty sure that's what I wrote right here. And the initial velocity is 2 feet per second. I'm pretty sure I put that right there. Well, everybody, I want to know what? I want to know v of 80. You guys agree? Which rocket's traveling faster at time equals 80? Okay. Everybody, I can always find, all right, the velocity. And I can do this as a fundamental theorem of calculus, because we can find the velocity of rocket B by integrating the acceleration of rocket B. Right, guys? Because if the derivative of velocity is acceleration, what's the antiderivative of acceleration? Velocity. All right? So I'm just going to integrate, and again, this was a 3t plus 1 to the negative half dt. If I integrate this, all right, and this is a good case where I get lucky. I don't have to do a u substitution. I add 1 to the power, right? Ignore the 3. Divide by the new power, because t plus 1 works out. And then what am I missing? Well, not just units, but plus c. So I do a little stretch, pull, twist. I think I get this. Now, I gotta know what c is. You guys agree? But I had an initial condition. All right? I had an initial condition. All right? My initial condition is when the velocity is 0, right? When I plug in 0, I get a...
So isn't that when you plug in 0 to the failure one? I'm so confused. Like, you switch from A to VB,
Well, this equation here, all right here, was the is the acceleration of rocket B.
I got the B equals 0 was from up above, not from question C.
Yeah, and they gave right here. They gave the initial condition for rocket B in this sense.
I get that now.
Okay, so everybody, I'm gonna figure out C using 0 and 2. I get 2 equals 6 plus 1 to the half plus C. That's 6. Guys, I get negative 4 equals C. So my equation now for this problem, for velocity of rocket B at time t, is 6t plus 1 to the half minus 4. Well, what did I want to know? I want to know the velocity of at 80 seconds, right? So I do velocity of rocket B at 80. And this is where I feel pretty good about what I've done. Because everybody, what's 1/2 of 81? 9. We're feeling really good about this. 54 minus 4, I get that this is 50 feet per second. So I get the velocity of rocket B is 50 feet per second. It's a little hard to do, but I'm going to go all the way full screen for a second, entire page. Velocity of rocket A at 80 from the table, right, is 49 feet per second. So which rocket's faster? Rocket B, all right, is traveling faster at time equals 80. And that is the AP problem. Listen, if you got this without constant C, that was a point. If you had plus C, give yourself a point. If you used the initial condition, you gave yourself a point. And finally, the last point was saying that 50 is greater than 49, but the other point was all the units being correct, A and A, B. And that would be your 5. Everybody keep grinding, all right? And keep practicing.